There we are. Hi, everyone. I'm Bill Messing. I'm founder and CEO of Orca Mobility in Seattle. Many of you have seen these classic images showing just how inefficient automobiles can be at moving people up and down the roadways. But did you know the same thing is true of cargo and trucking? Everywhere you look, you can find 8,000, 10,000, 12,000 pound trucks being dispatched to deliver an 80-pound load. Each of these trucks can put 40 to 60 tons of CO2 into the air every year. And at that, even though they're usually running around mostly empty, they generally cost at least twice as much to operate as a semi-truck even. And that's not even considering issues around congestion, curb use, land use, all the rest. It's a train wreck. At Orca, we're out to change all that. We're out to displace millions of diesel box trucks, vans, even automobiles with much smaller and smarter driverless cargo bots. 3 feet wide, highway speeds, and the speed is important. Purpose-built for micro-logistics. The main cargo bay can swallow up a dishwasher. We're also going to do a smaller version that's ideal for doing things like carrying a laptop from one Best Buy to another. In other words, ultimately we're going to be operating literally the smallest truck on the highway. How do we do it? We lean like a motorcycle. This may be a little counterintuitive, but that is what allows us to travel at highway speeds, even with the tiny form factor. This is my last company, Tilting Motor Works. We had 4 issued patents. I founded Orca because I knew this IP inside and out, and I know how powerful it is, I know how difficult it's been to imitate, and it defines a whole new class of really extremely efficient vehicles that aren't attainable otherwise. When you look at the whole spectrum of cargo vehicles, you'll find all these highway speed vehicles to the left that are all 6, 7, 8 feet wide, and that extra size makes them heavy. It makes them costly to operate. It makes them less maneuverable. To the right, you see all of these highly efficient vehicles that have been developed all over the world to navigate in congested urban areas. What they all have in common is that they are slow. They're all speed restricted in various ways to 20, 25 miles an hour. Why? Because if they go any faster than that, they're going to fall over when they go around a corner because they don't lean. Orca is actually the only vehicle that brings that compact form factor along with highway speeds. So that opens up all kinds of new scenarios. Instead of loading up a box truck to go on some circuitous 130-mile route, which is sort of the norm, instead we can fulfill orders ad hoc, all day long, out the door, down the road they go, repeat 5 minutes later. We're talking to some very large enterprise customers who have needs very much like this, a large automobile parts distributor, a big grocery chain. These are companies that operate thousands upon thousands of vehicles. Our value proposition to them is quite simple. By removing the driver, you remove 30 or 40% potentially of your operating expenses. In our case, we also improve the service levels because we're able to improve the fulfillment times by fulfilling continuously all day long. Continuous fulfillment also happens to have a lot of appeal in manufacturing because when you're servicing a high-speed assembly line, you've got to keep feeding that line all day long, and a box truck is not necessarily the best way to go about it. We are exploring last-mile scenarios like this one, but really the sweet spot for us, particularly as the AV stack matures, is much more around middle-mile, B2B, repeatable routes where we can go back and forth in known terrain. Trucking is big business, I'm sure you all know, but the money is not so much in selling trucks, it is in operating them. Same is true in our forecast. As we go along, the operations of these trucks actually generate a lot more revenue than just selling the hardware. The climate impacts are just as stupendous. If you take 1 million of these diesel trucks off the road, we actually can remove 85 million tons of CO2 year after year. That's 85 megatons. It's a decent number. The core team here is Bill, Mike, and Steve. Mike is the CAD designer, machinist extraordinaire, mechanic. Steve designs motor controllers and battery management systems for Tier 1 automotive suppliers. And together, we have the background to actually design, build, and ship original vehicles. We've already taken a couple of these tilting motorworks vehicles and modified them. We've instrumented them to capture all the vehicle dynamics. And with that data, the next step is to jam it into a machine learning environment and teach this vehicle how to go by itself, by which I mean teach it to self-balance, teach it how to follow a path. That is our proprietary technology. We're not going to reinvent the wheel on the AV stack. We don't need to put the AV stack on here until this predecessor task is complete. But in the meantime, we see the incumbents all sort of improving by leaps and bounds year over year. That's going to take money. Today we're announcing an $11 million seed round. We will take the first $2 to $3 million on a note to build up the production prototype or the selling prototype, call it the MVP if you will, to land our first 2 pilot deployments, probably one in Europe, one in Japan. That'll demonstrate the value proposition and help us build the business case going forward. So you may ask, what's the single most impactful thing I can do to mitigate emissions, to alleviate congestion, all these good things? Is it to take out the recycling again this week? Maybe not. Is it to buy myself a second Tesla? Maybe not. Is it to join with Orca and figure out how to bring this highly capable, highly differentiated vehicle to life in the market and get all of those diesel trucks and vans off the road once and for all? Look forward to speaking with you. Thank you.
All right, I'll go first. Hi, I'm Jance from LACI. Thanks for the
Janice.
presentation, Bill. My first question is just about you spoke to plans for a couple of pilots.
I'm going to stand over here so I can hear you better.
Okay, sounds good. You spoke to some plans for a couple of pilots.
Yes.
I'm curious how you would measure the success of those pilots, what some of the goals would be.
Well, we're hoping to do one in warehousing and one in manufacturing. So in the warehousing, it's a question of can you improve the throughput and the fulfillment times for the customer, and that kind of depends on the individual needs of the customer. In manufacturing, that really comes down to the suppliers of the manufacturers, and can they move parts to the line with less infrastructure, less congestion, less labor. And they measure those things, to a 10th of 1%, to a 100th of 1% all day long. That's what they do. So we've got to embrace their metrics and collaborate with them and beat them.
Hi, David from Autotech Ventures. I wasn't sure if I heard correctly. Are you planning that you're going to license an AV stack, or you're planning to eventually develop your own?
We will license. Okay. Nobody is going to have an existing stack that just works day one, so it's probably going to involve licensing different components from different parties. We don't need to do that today. We need to do that in about a year. But no, we're not going to reinvent the wheel on the AV stack any more than we would ABS. We're an integrator. Our value proposition is in the vehicle form factor and in the special capabilities that it has.
And so will there be a form factor that has a driver, a human driver, or is it going to be only AV?
Negative. There will not be this is by definition an AV.
Okay, thanks.
Hi, Tiya Gordon, itselectric. So I like the diversity of the business model in terms of middle mile and also warehouse solutions, but given that you're AV, those are two entirely different practicalities in terms of execution. So in terms of the fact that you're raising to prove a concept, what is the core concept that you're looking to validate?
That this vehicle can go places and do things that no other vehicle can do, that it uses much less real estate. Obviously, it uses less labor. You could say that about any AV. It uses less fuel. You can say that about any electric vehicle. But to put all those things together with the compact form factor and the higher speeds, there's a whole long tail of smaller payloads, whether it's manufacturing or warehousing, that doesn't need to travel on a full-size vehicle. And that goes for even a Prius. So it's a question of can you service those needs more efficiently, more effectively with a smaller vehicle, and in fact, the smallest possible vehicle. That is ultimately the value proposition. Can we produce the smallest possible vehicle that can travel at highway speeds? Because we're talking about runs of 5, 10, 20, 30 miles, things that an e-bike can't do.
So if we're looking at that, and we're looking at sort of like the nearest comparable, let's say like the Rivian Amazon truck, right, which is not huge, but it can still contain a lot of
500 or 600 cubic feet. Yeah.
It can still contain a lot of space for material delivery.
Yep.
What's the disadvantages of that, which is human-driven, versus AV at a smaller form factor that still requires human automation?
Parcels and B2C are kind of a different animal because, I mean, they're running those trucks because they're servicing densely populated areas and they need to get the package from the curb to the door. We're focusing on the middle mile and the B2B for that very reason. There's somebody on the receiving end. It might be the guy who's fixing your car in a service station. When that catalytic converter comes in, he's going to walk out and he's going to retrieve that thing. And that's, you know, that's something you can definitely do with a big Rivian truck if you want. But it's somewhere around 8 to 10 times the size that it needs to be, and the battery is about 8 to 10 times the size it needs to be. And, you know, particularly if it has a driver, there's only so many stops you're going to make during the day, as opposed to being able to fulfill orders in parallel the way you can do with multiple smaller vehicles. It's mind-bending. It's not, I mean, this is not anything that exists today. There's all kinds of potential, and we're exploring that. We're getting cut off, but I'll find you afterward.
Yeah, sorry. Thank you. Only questions from the panel of experts. Oh, thank you. But yeah, feel free to connect right after the session. Thank you, Bill, for doing your pitch in 6 minutes. Next one, we have iCOMAT all the way from the UK. iCOMAT is handling the revolutionary production equipment for the manufacturing of advanced carbon fiber composite parts. Welcome to the stage, Evangelos Zympeloudis.
Hello everyone, I'm Evangelos. I'm the CEO and founder of iCOMAT. At iCOMAT, our mission is to produce the world's lightest components, and this is for cars, for planes, and even spacecraft. So the problem we're solving is weight. Okay, 1 second. Yeah. And this is a big problem across the transportation sectors. If we look at automotive, this is driven by the mega trend of electrification, where electric cars have really heavy batteries and their weight has ballooned, even up to 3 tons for the case of some premium SUVs. And then you have anything that flies, and whether it's a plane or a rocket, weight is hands down the #1 driver. And the bottom line is, our society demands faster, cheaper transportation, which is also environmentally sustainable. And to do this, we need better lightweighting technologies. And that's where iCOMAT comes in. We have developed a process that can produce, hands down, the lightest vehicles possible. And in this slide, you see some examples of different parts for aerospace and automotive that can achieve up to 65% weight reduction. And this has been validated by some of our blue-chip customers, companies like Airbus, BAE Systems, and Jaguar Land Rover. The best part about our technology is that it can translate across the entire structural stack. So from airplane wings to rocket bodies and car doors, we can produce the lightest components possible. Overall, this market is worth over $1 trillion, and our aim is to dominate and become the new manufacturing standard. And lastly, lightweighting is one of the best ways to decarbonize entire fleets. The more weight you reduce, the less batteries you need, the less CO2 you produce. Now, a little bit about our technology. So we work exclusively with composite materials and carbon fiber. An example of a material like this is on the left-hand side. Effectively, they're textiles. They're made out of millions of very strong fibers. And what is peculiar about them is that they are only strong in the direction of the fibers. And today, we don't like that. So the way we design and manufacture is by stacking straight fiber layers across the different orientations. And that gives us roughly the same strength in the main directions. A structure is never loaded the same in the main directions, so we end up placing a lot more material than we actually need. And it would be far more efficient if we could steer the path of the fibers. And in such a way, we can reinforce a structure only in the critical areas, giving us components which are lighter and perform better, but also require less raw materials, so they are cheaper and they are faster to produce. And this concept was developed in the 80s by NASA. There is a lot of publications around it. The one bottleneck always has been manufacturing. It's impossible to manufacture using fiber steering with today's technologies. And what we've done is develop the world's first machine and technology that can fiber steer with absolutely no defects at all. It's patented and is based on 10 years of R&D at the University of Bristol and 4 years of industrialization at iCOMAT. And as you can see, it's completely defect-free. And now we'll see a video on how you can use this technology in actual production. So we've selected a curved beam. It's a component that is widely found in cars, but also in aircraft. And to be exact, in the Airbus A350, there are over 1,000 curved beams like the ones that you see here. So what we're doing here is we're using a workflow that has been developed for the automotive industry. So we start with a flat stack of carbon fiber plies, and our machine deposits them. And from this stack that you see here, you can make multiple curved beams. So then at the next stage, we will take this stack, and you will see there will be an ultrasonic knife that will cut out individual preforms. And then you take those preforms into a forming stage. Now, this workflow here is not possible with traditional composites. Carbon fiber is so stiff and so strong that if you try to bend it or form it in any shape, it cannot extend, and it forms wrinkles. Now, with our technology, we can predict where those wrinkles are, and we pre-steer in 2D so that you can form in 3D with absolutely no defects at all. And this is a game-changing workflow. As you will see here, you can make defect-free components at a fraction of the time and at a fraction of the cost. And this is the end result. It's drastically lighter than traditional composites, but also the unit economics are an order of magnitude better. Just to put this into context, this is how Airbus makes beams like this today. So you do direct layup. These gaps that you see here are actual defects, so you need to add extra material. And it takes an eternity to lay this up. It takes 8.5 hours today in production to lay up a beam like this. With our technology, we can do it in 5.2 minutes. And we can do it without defects while saving 20% weight. Our go-to-market initially focuses on high-value, low-volume applications like defense, drones, and Formula One, where we already have our first customers in production, and gradually ramp up the volumes until we reach the mass market, both in aerospace and automotive. And that is a tried and proven path. This is some of the contracts that we have over the last 6 months. We've booked over 6.5 million in revenue this year, and it's growing by the day. We've got 5 separate contracts with Airbus, companies like BAE Systems and Mitsubishi Heavy Industries in defense. And then in automotive, we're working with Jaguar Land Rover, Hyundai, and Formula One. We've secured significant funding to set up our first production facility in the UK. And this will be a state-of-the-art facility. The overall value is over 10 million, and we'll have 3 production lines, using our technology, capable of producing any component up to 12 meters. We're now in the process of raising our Series A, 16.5 million to convert our first opportunities into high-volume production and also expand in the US. Out of this, 9 million is already in our bank through a convertible loan note, and we expect to close the full round within the next 4 to 5 months. And before I conclude, I want to leave you with an analogy. The truth is that carbon fiber today is still a niche, exotic material, a little bit like what steel was in the late 1800s. Back then, they used steel to make forks, knives, armor, really silly things. And then Bessemer and Carnegie came along, and they found a way not to reinvent steel, but to make it a little bit lighter and a little bit cheaper to produce. And that gave us railways, skyscrapers. Effectively, the American Industrial Revolution was based on this development. And in the process, they made the most valuable company in the world at the time. Now we're at a similar point in history where we want flying cars. We want to electrify fleets across aerospace and automotive. And this is simply not possible and not sustainable with the technologies that we have today. Carbon fiber is by far the best engineering material to do this, but there are technological barriers that have hindered its adoption. That's what iCOMAT is addressing, and we can have an impact of similar magnitude. Thank you very much.
Thanks for that, David from Autotech Ventures. For your business, are you selling the machine, the process to customers, or is it a subscription model? How exactly are you going to market?
We're effectively a tier 1, so we sell the end components. The way we can make our factories is very scalable, so in terms of CapEx needs, it's 3 times less than what you would need for traditional production. because we're using effectively a tape-laying system and a forming step, which is pressing or effectively a forming machine, which is technology already well developed for the automotive industry. So we're a tier one. We sell the components.
Got it. So you sell the components completely custom made to spec to the customer on the factory essentially.
We can do it build to print, but most of our customers they usually want us to design because they want to fully leverage this technology.
Got it. Thank you.
Hi, Tiya. Who are your competitors in this space in regards to carbon fiber and customization?
In terms of steering and leveraging this technology, there is none, and that's why we have this much traction. But having said that, I would say that our main competitor in entering the mass market is metallic production, and that's what we're aiming to beat, and we can be competitive with aluminum casting up to 400,000 vehicles a year.
Great presentation. This is Pamir from Blackbird. I want to understand, when you produce composite materials that are bent, what are some of the changes in performance, especially for, let's say, aircraft? In terms of durability, in terms of strength, it must perform in a different way. So maybe you can elaborate a little bit on that.
Yeah. So maybe if I illustrate this with an example. So we've just completed a contract with the European Space Agency on a rocket launcher structure. We gave them 20% direct weight saving, but we gave them a 300% increase on effectively the insensitivity of the structure to imperfections. So that's a big problem in space structures, damage tolerance, and if they have imperfections, that initiates failure. So we're able to increase that by 300%. So overall, it's a better way to design. If you look, for example, at nature, anything that has a fiber, it has steering in it. And that's why NASA originally developed this technology. The big barrier has been manufacturing, and that's what we've cracked.
I just wanted to, I'm Jance from LACI, hi. You had talked a little bit about sort of some of the applications for this and gave one of the examples as looked like kind of like a luxury vehicle. I'm wondering if you could talk a little bit more about some of the other applications. Yeah.
Yeah, so I think this is a big challenge with a business like this, the sales cycles. So that's why our roadmap initially focuses on, as I said, high value, low volume opportunities. For example, Formula One, where you will see us in one of the teams next April, where the sales cycle is really, really short and you can get market penetration. And then you gradually ramp up the volumes. And if you look at a luxury vehicle, the structure, the basic structure is exactly the same like, let's say, Toyota Prius. So you can prove the technology there, and then when cost becomes more of a factor, you can effectively scale it up. And I have to stress that that's how the automotive industry works now. Yeah.
Thank you so much. Great job. Okay. Last but not least, we have CoFlow. CoFlow has developed the advanced stationary CoFlow jet cylinder wind cells to harness propulsive power from ocean wind for marine shipping decarbonization. Welcome to the stage, Jance.
Thank you. I don't need this.
Oh, that's my microphone. You need this.
Okay. Hello, my name is Gecheng. Our company is called CoFlow Jet Lift. I'm also a professor at the University of Miami. So you can see that we're trying to do decarbonization of marine shipping. So why do we do that then? Actually, marine shipping is a very big polluter. When we talk about decarbonization, we are thinking aviation, automotive, but obviously we cannot forget marine shipping. 90% of the goods in the world is shipped by marine shipping. So just in 2019, as an example, the annual CO2 emission is about 1 billion tons. The fuel cost is 165 billion. One of the largest ship here is Evergreen. The annual emissions equal to 50 million cars. I feel sorry for Tesla. Next 30 years, their production will be wiped out just by one ship. And how many ships we have in the world? The fleet is 100,000. Of course, they are not such a big ship, but they are pretty substantial. And that lines are the Google map of all the shipping lines in the world. Every instant, there are many, many ships traveling in the world. Okay, so what is the problem in current technology? There are three technologies trying to use wind to generate the propulsive power. Oh, sorry. One is flattened rotor, that's on the left. It's a very massive cylinder, need to be spin very fast. It's not trivial to spin such a large structure. We all probably have experience. Even you have a fan, if it's not well balanced, you will hear the wobbling noise. The second technology is called the turbo cell. The advantage of that one is that they don't need to spin, but they suck in air along the cylinder to generate the high lift. And the third one, simply using aircraft wing to generate lift. Advantage does not need to spin, but disadvantage is the lift coefficient is much lower than the other two. Okay, so what is our solution? That is the CoFlow jet technology. We're also using cylinder to generate much higher lift coefficient without spinning. So the trick is that we put a fan inside the cylinder. When the air, wind coming from the side, we suck in at the 4 o'clock position, pressurize, and eject at the 12 o'clock position. It generates very high lift without the spinning. So structure-wise, it will be much simpler. So the technology is originated from aerospace engineering. Actually, I'm a professor in aerospace engineering. We have been funded by DARPA and NASA. So it's with 17 patents already issued, 20 years research, we got $2.5 million just from a government grant. We are still working for aviation. Actually, NASA invited us recently to write a proposal to fly on Mars. We may be the only one can fly on Mars because Mars is very, very thin. You need a very high lift coefficient. Actually, the chart on the very right is an example of lift coefficient of CoFlow jet compared with the baseline. You can see baseline maximum lift coefficient 1.4. We get 9. Not just that. The drag of the baseline is all positive. We got a very big negative drag. What does that mean? It means it's a thrust. So here's the comparison of CoFlow jet cylinder with a flattened rotor. Without spinning, we generate much higher lift coefficient with power compared to with a flattened rotor. So the benefit, we aim to reduce 20 to 50% fuel reduction for cargo shipping. We are aiming to begin with large sector of cargo shipping, but the technology can be used for all ships, fishing boats, recreational ships like yachts. So because it's very simple and safe and reliable. Think about if something in your ship is spinning like a flattened rotor, you will not be able to go close to the system. But for us, it's very safe. So the market of just the cargo shipping for the wind propulsion, the projection is $240 billion by 2040. By 250 would be $600 billion. So our business model is licensing, manufacturing, sales, and leasing. So we are hoping to become a 5 to 10 billion company in 10 years. In 20 years, to become 50 to 100 billion company. In other words, we want to be the iPhone in this market. We want to be the dominant player. And here is the potential customers and startup. On the left is the shipping line, the OEMs, potential customer and partners. On the right is our competitors. They are mostly, actually almost all the startups in Europe. We may be only one of the few in US. One of these large companies just invited us to visit their headquarters in Geneva. I don't want to say which one. They may become our strategic investors. Oh, I'm sorry. So we are just closing 1 million pre-seed money, and probably this month. And we are open up for 5 million seed money, and 20 million after will be Series A. We are hoping using this money to develop a pilot program overall within 3 years so that we can deliver the products. We already have a pilot, a company working with us for pilot program. It's a shipping company between Miami and the Bahamas. So I'm sorry, have 17 patents already issued, and we have more patents pending. Here's our team, myself, and Dr. Ren is our CTO, Hagen Ruff is our VP, Renee and all others are advisor. Renee is a marketing expert. Dong is a recently retired Boeing engineer. Nancy is a licensing expert. Saeed is a very savvy business person. And Kaming is a ship designer. So here's our partners. You can see many government agencies. We already also, I graduated from Rice Clean Energy Accelerator. I also graduated from third derivative cohort. We also got some money from them, and the Pan Americans helping us to raise money. So that is my presentation. Questions?
Aaron from South Coast AQMD. A couple of questions here. So what is the power requirement to drive that pump? Like how much auxiliary load are you talking about for each one of these?
Very good questions. Very small power is about 1/10 of the power we can get back. For example, we generate a megawatts propulsive power, we will spend 100 kilowatts. So just using very small power, we'll gain a lot of wind power back as a propulsion.
And then for the cargo container, how do you handle the ship-to-shore cranes at the ports?
The container is more challenging than this bulk ship, but you can see the MSC design, the way we design is that to let the cranes mostly doing just in the horizontal way. So, and also all the wind sails can be tilted down when necessary.
I'm just thinking of the downside, if you have a headwind, at some point that headwind's going to overcome your system and that'll be a drag on the propulsion. What's the wind speeds that you would...
If it's complete headwind, we have a way to relieve the pressure, to relieve the drag. Actually, it's not hard to think. It's in one of our patents. You can see that we have holes, the slots, right? So I don't want to talk about details, but we already considered that.
Very much,
Yes.
Professor. I just want to understand a bit more on where the product is today. Do you already have maybe a subscale prototype on the maritime?
For maritime, actually, airfoil is the same as the cylinder. We already test this in wind tunnel testing. This is that's me. So you can see it's a pretty big airfoil. Actually, if you study aerodynamics, the cylinder is one of type of airfoil. They are the same thing. So we already did that, and the money we will get will optimize the cylinder, and we will also do the testing.
A quick follow-up there. How much capital do you think you will need to get to maybe a very quick subscale prototype and put it out on the water and actually, propel a naval craft?
We would feel more comfortable with the $25 million. Because there's a lot of engineering and manufacturing control. The whole system will be fully autonomous. That's what we are aiming for, $25 million. So in other words, with $25 million, we are fully ready to deliver products to everyone, including installation. Yeah.
Thank you so much for the presentation. So the environmental impact is clear, and there's a reduction in fuel costs when we're not able to be fully wind powered. Who are you selling to, and what is the benefit for them wanting to buy this product as opposed to what's currently on market?
Shipping lines is one customer, of course, the OEMs, because fuel consumption is 30 to 50% operating cost now. If we can save 10% or 20%, that's very enormous.
So the savings is in the fuel cost, or is there also a speed component in terms of the freight
speed,
travel?
whatever speed that they prefer to use, we will save their fuel consumption.
Okay.
Just give one example how expensive a cargo from China to US, 28 days round trip, the fuel is $6 million, just one ship. 1 year will be about $70 million. If we can save them 20%, we're talking about one ship will save $14 million. Wow. So,
Thank you.
Yeah.
Thanks for the presentation. Just a quick question with respect to when the wind isn't sufficient. Are you envisioning kind of batteries? What other propulsion can the maritime vessel be leaning on?
Yes, actually, that's a very good question. We would like to use battery for this wind cells power. So in other words, that will be partially electrified for the overall shipping system.
So it's optimized for electric, like already electrified
Yes.
boats?
Yes, all the fans are powered by electricity.
Okay, thanks.
Thank you.
Thank you so much. That was the final pitch for CoMotion LA 23. Thank you to all the startups. Once you get your Series A, Series B, don't forget about CoMotion and share your story with us here on stage. Thank you so much to our panel of experts for all the hard work and the great questions. And as a quick reminder, we'll be announcing the winner during the closing remarks later today, 5 p.m. So good luck to all the startups. Thank you.